Welcome everyone to the Kubernetes SIG Storage Onboarding topic meeting. These videos are organized to help people quickly onboard to SIG Storage. Your questions and comments are always welcome. Today we are going to be presenting two topics. The first being Kubernetes CSI Kubernetes workflow and architecture in terms of SIG storage, and our presenter is Vladimir Vivien. Go ahead and take it away, Vlad.
Thank you very much. I'll go ahead and share my screen.
We are seeing your screen now. Thank you.
Okay, excellent. All right. So you should be seeing a CSI workflow and architecture title page. So basically, well, how long do I have, Erin? About 10 minutes?
5 to 10 minutes is what we'd like to limit it to.
Yep. Okay, yeah, that should be plenty. Hi, my name is Vladimir Vivien. I work for VMware. I'm part of the cloud native unit there, where I work on cloud native stuff, including Kubernetes. So today, real quick, we're gonna do a super high overview of CSI and how to get basically the flow of CSI itself. So this is the agenda. We're going to look at Kubernetes storage, the container storage interface, and a high level overview of the CSI architecture. So let's start with Kubernetes storage. Kubernetes storage subsystem, as you probably already know if you've been using Kubernetes for a while, is declarative, uses declarative primitives such as PV and PVCs to declare both available storage and storage consumption. The orchestration by Kubernetes support both file and block, including persistent, ephemeral, and local storage. And then the ability to provision, attach, mount, and delete storage resources is also supported by the Kubernetes storage system. The storage subsystem, as we'll see, uses a plugin architecture to support many storage providers. Now, why do we need CSI? Well, so CSI is an independent interface specs that describe or specify how container orchestrators and storage vendor can provide storage operation in Kubernetes and other container orchestrators, not just Kubernetes. The specs is defined by a diverse community of vendors, and again, the storage orchestrator providers such as Mesos, Kubernetes, Cloud Foundry, Dockers, etc. The interface operations are defined using gRPC, and we'll see in a few slides how that is done. And is designed to be portable, and the reason why we need portability is because conceivably, once you write a CSI storage driver, it should conceivably work regardless of the environment where it's running in. So before the Kubernetes CSI, what did we have? The Kubernetes plugins were implemented in tree directly into the source code of Kubernetes, of core Kubernetes. Now, what that created is many heterogeneous implementation in the code base directly. While it made deployment easier, but what we ended up with is a growing list of plugins from different contributors, which eventually caused the volume subsystem to become large. And part of what drove Kubernetes what drove CSI, beside the fact that we're having a large growing code base inside Kubernetes, is the actual implementation of plugin for storage inside Kubernetes directly, which can be a painful endeavor if you ever had a chance to go through that. So what does Kubernetes bring? Kubernetes CSI inside Kubernetes supports an out-of-tree plugin architecture, and the plugin architecture uses gRPC to stand up CSI storage drivers that communicates over gRPC. A driver can be deployed as a regular containerized process right on top of the Kubernetes cluster itself. Although that you don't have to, but that's something that can be done. And then the cluster workload works as is done currently, where you can consume storage using existing declarative primitives such as PV and PVCs. Now let's take a look at the CSI architecture itself. There are three main components when we're talking about CSI inside Kubernetes. You have core Kubernetes, which is the kubelet, which still is responsible for the coordination of storage, and then you have the external pieces of the drivers that are responsible for partly to handle the storage operations supported by the drivers. Now, so the way the CSI has been implemented is that we still have an entry CSI driver that lives inside Kubernetes, but its role is strictly to orchestrate and talk to external drivers. It doesn't support it itself doesn't provide any volume operations directly. So one of the pieces we have is a daemon set pod that basically provide registry and the CSI drive and a CSI driver that when CSI is deployed on all the nodes that need storage, that pod will be able to service that. And then we also have a stateful set pod, which supports or hosts an external attacher and external provisioner, as well as pieces of the CSI driver that can support attacher and provisioning operations. And then down here, what we could see here are the pieces where the driver communicate with Kubernetes over socket. So what we have is a Unix domain socket for the CSI driver to talk to the core kubelet here, and we have the same thing here inside this piece here, where we have the CSI driver can talk to an external attacher and or an external provisioner all over a Unix domain socket. And the way that is done, we won't go into the detail how that is done, but basically these pieces talk to Kubernetes using a TCP over a Unix domain socket, and the CSI driver exposes several methods for storage operation, and that is how Kubernetes talk to the external drivers. And then so at this slide basically shows the higher level components, and once you deploy those components onto your cluster and everything works properly, you should be able to use a CSI as designed. Now, I did not go into further detail as far as the actual deployment and excuse me, an actual design implementation of an actual driver, but hopefully this gives you an idea of the high-level pieces that are involved in creating and using CSI. Erin, what was my time? I think I'm good.
You're good.
Okay. Yeah, I think that's all I have.
Okay, well, at this point, we'd like to open it up to anyone on the call to gather your questions and respective answers. Okay, well, if there are no questions, I'm going to close this recording and we're going to move on to the next topic, which dives a little bit deeper into CSI. Thanks, everyone.